Okay, good afternoon. Just check my voice is audible and screen is visible.
Yes, sir.
Yes, sir.
Are you observing screen?
Yes, sir.
Yes, sir.
Very good afternoon. So what we have seen till now, so almost statics part we have covered. Okay, in which we have studied 3 chapters. Which are they? Can someone tell me quickly what are the names of first 3 chapters? Today we are going to start chapter number 4. Okay, I will give opportunity to tell the names of our chapter 2. Let us say Supriya, roll number 2. Supriya Bahirgonde. Please unmute yourself.
Yes, sir.
Yeah, okay. Will you tell what is the name of chapter number 1, 2, 3? Supriya.
Resultant of coplanar forces.
Resultant
Second,
of,
equilibrium of rigid bodies.
okay. Third one is
Second, equilibrium of body.
okay. And what was the third, which we have seen recently?
Analysis of pin jointed and plane forces.
Analysis of pin jointed plane frames. Like what's the name of the chapter? Or very good. You tried very good. I appreciate. At least you immediately you told the names of the chapters which we have studied till now. So chapter number 3 in short we can say truss. Famously, it is known as truss. Analysis of pin framed plane frames. Okay, pin joint plane frames, or we can say truss. Simply it is the meaning of truss. Okay, so what the way I have told in first lecture itself, maybe first or second lecture. This subject is divided into mainly two parts. Okay, section 1 and section 2. Out of that, 4 chapters are there in each section. Section 1, 4 chapters, section 2, 4 chapters. Out of that, first 3 chapters are correlated to each other. So that's why we have taken a lot of time. Almost till now, if I'm not wrong, 55 to 60 lectures are taken by first 3 chapters. So hereafter, that many lectures are not required for remaining, we can say, for 5 chapters. Okay, because things are simple. These are not correlated. This chapter number 4 is totally different. I will say different in the sense it is not related to chapter number 1, 2, 3. Okay, and thereafter chapter number 5, once we are going to start the dynamics. Okay, so chapter number 5, 6, 7 are related to each other. Chapter number 8 is totally different again. It is only theoretical chapter, chapter number 8, vibrations, mechanical vibrations. So in which again no problems are there, only we can say simple theoretical part is there. So if I will define our journey of our we can say syllabus coverage. Okay, so it will say we have started something like this. If we have started the journey of our subject, okay, so how we have started, and if I will draw a little graph, just we will discuss the things today. Okay, in this way, or more simple again. I am unable to draw this. Sorry. Are you observing the screen?
Yes, sir.
There is a problem. Okay, so if you see syllabus coverage, so first major 3 parts, 3 chapters we have covered, which will take more time. Okay, so almost I will say here at this stage, almost 60 to 70% syllabus is over. 60 to 70%. Okay, I will say 60, not 70 also. 60% syllabus is over because that part is the major part from the we can say mechanics. Okay, if you'll see the journey of our syllabus coverage, if I will draw the graph suppose of our syllabus coverage, if I want to draw suppose something like this, we have started again in this way something. Okay, something like this, here to here. Suppose our subject is something like EM. So we are at here, means we have reached a fixed point. As far as don't compare with chapter numbers. actually we are here right now. आपण इथपर्यंत आलेलो आहोत. Only this much part is remain now. Very simple. More than 50% we have did our journey. So you should be on your toes. You should be prepared, well prepared for the exam. You keep in mind. Hereafter, quickly syllabus will get over. I'm not going to miss the lecture as far as possible. We will take our lecture first, and thereafter we will catch to other lectures as well. So that I want to know if, and you should be with your notebook. Always I am telling. So if fortunately thing will happen that you are supposed to come college, so you should be with your notebook. If again that notebook should be completed one, so it should not happen that you are going to purchase notebook from the shop, okay, or from the general store, and you are coming to the college with blank notebook. If your notebook is blank, that means you are outside of the class. It may be the reason. So completed notebook should be there, completed. So I'm going to check completed notebook for my subject, irrespective of, so whatever. Once you will attend the college physically, maybe, may possible. So in that case, your notebook should be completed one. Still time is with you. If you have not written earlier problems, etc., you can take help of your friends and you can complete. Okay. So let me know presence of mind. Once again, I will ask same question to Avinash, 53, roll number 53.
Yes, sir.
What are the names of first 3 chapters? Is it possible for you to tell? नाव सांगा चॅप्टरची, कुठले कुठले शिकलोय आपण आतापर्यंत. How many chapters we have studied and which are they?
Sir, mechanics.
Mechanics. Mechanics काय आहे? What is mechanics? Which are the names of first 3 chapters? Nanavre or Naik Navre, what is name? Nanavre. Avinash, 53.
Yes, sir.
हा, सांगा तुम्हाला काय आठवते ते सांगा. आपल्या आठवत नसलेलं तर दुसऱ्याच्या सब्जेक्ट सांगा, सांगा. फर्स्ट 3 chapters. Name of the first 3 chapters. आठवतंय? Are you remembering you are in first year, division F? Your roll number is how much? 53. You are studying certain subjects. At least that thing, are you aware about?
Yes, sir.
From where you are? Which is your native place?
Wonderful, sir.
Living very near to
Bandisha.
college. Okay, it is also near. Don't worry. Hardly 20 minutes are required to come from Bandisha to Pandra. Let it be. So I hope I'm going to check notebook. That you keep in mind, and definitely you will be in college premises very soon. Who is raising hand? Somebody has raised a hand. Who is it? Is there any issue? If not, now you analyze yourself. I will not ask. I will not waste time asking such questions. Just I was checking. Are you aware about? Are you with me? Or just you are logging in is not sufficient. I told only logged into Zoom or entered in the division link. It doesn't mean that you have understood the thing. So that you keep in the mind. Just I have taken 2 sample cases. Sample. So you might be knowing sampling. You will learn in your future, in your further classes, higher classes. You will learn what is sampling. So you can see. Suppose there is a practical example. Suppose there is a truck of suppose something, maybe banana, or we can say apple, or whatever fruit. So what customers in general, we can say that businessmen, something, what they are doing, they are just taking one of the sample. त्या ट्रक मधून ते पूर्ण ट्रक चेक करणं शक्य नसतं. तर काय करायचं, एक सॅम्पल घ्यायचं. वन सॅम्पल दे विल टेक अँड दे विल चेक. आफ्टर दॅट दे विल डिसाइड what is going on into the right now in the class, in that case in that truck or whatever that vehicle it is there. It is done sampling. एकच क्रेट काढायचं, सपोज टोमॅटोचा ट्रक आहे तर एकच टोमॅटोचा ट्रक रॅन्डमली उचलायचा कुठलाही आणि चेक करायचं हाऊ इट इज. Then they are going to decide quality of all the tomatoes, bananas, apple, whatever it may be. So likewise, I have picked only 2 students from the class, roll number 2 and 53. Roll number 2, she has given at least the names of the chapters, means 50%. I will say out of 2, one has given correct answer, means 50% attentiveness is there. I'm going to come conclusion. With these 2 sample cases, we are at 50%. 50% students are serious about online teaching. Okay, so unit number 4. Once again, I will repeat. Unit number 1 we have seen. What was that? Resultant of coplanar forces. Resultant of coplanar forces. We have started our subject from where I have shown planes, how to divide the force in the plane, etc. Many more things. Okay, then how to resolve the force, then different principal directions. N number of things we have seen. I will not repeat now. Then second one we have seen equilibrium. The difference between a body is in a state of rest or stationary and equilibrium. We have seen that also. Irrespective of applying number of forces, body is at rest. That condition we are going to call it. कौन आहे? Who is that? Just check whether your mic is on off. At least that thing you should know because you are familiar with online teaching. Once we are going to talk something, we should confirm that our mic is on or off, whether we are unmute or mute. At least ते तरी समजावं आपल्याला. Okay, we are mature enough now. You have completed your 12th. Okay, you are adult now. Adult we can say. 12 plus 6, 18. You are 18 plus almost. म्हणजे आपण आता अडल्ट कॅटेगरी चाललेलो आहात किंवा गेलेले आहात म्हणून आपल्याला समजायला पाहिजे व्हॉट वी आर डुईंग. ओके, म्हणजे आपण गप्पा मारतोय 4 चौघामध्ये आणि आपला माईक चालू आहे असं असू नये. इट शुड नॉट, टाइम शुड नॉट कम दॅट आय शुड म्यूट युअर सेल्फ. दॅट इज वर्स्ट कंडिशन. लेट इट बी. Third chapter we have seen is there is a truss, or we can say analysis. Analysis means what? What I have told. What does it mean by analysis?
Find the forces.
Finding
Very good.
forces.
Finding the forces in the members. Okay. So what will be the nature in the force member? Nature कसं असू शकतं?
Compressive. or
Tensile or compressive.
How to identify compressive or tensile nature?
Towards the joint असेल तर compressive and away from joint असेल
Away.
तर tensile.
Very good. That thing only you have to remember. If you think more, you will get confused. Remember, once you are going to come to second year class, the concept is something different, other. That I will not go to that concept. Otherwise, you will get confused. Because so simple, you remember towards the joint, compressive. Away from the joint, tensile.
Tensile.
Why it is so? Why it is so? Because our truss is having certain constraint. Our constraint means, are you getting the meaning of constraint? Constraint म्हणजे काय? Constraint अडथळा म्हणूया आपण मराठीमध्ये. Constraint, it is not we can say open, but once you are going to study in your higher classes, especially in mechanical and civil, you will learn your component is free and forces are applied. In that case, that meaning may get changed, but I will not tell that because you will get confused. Meanwhile, you just remember towards the joint, compressive, away from the joint, tensile. That only you have to remember. That we have seen in types of truss. While analyzing the truss, 2 methods we have seen. Which are they? We have analyzed the truss.
Method of section.
Method of joint and method of section. So we have solved. You can solve a problem. Suppose we have solved the problems by method of section. You can try it for method of joint if you have interest. Those who are with me right from the beginning, they will enjoy the subject. And those who are not with me, they will enjoy on their own. So you realize this subject is very interesting, provided that you should take interest. So method of joint we have seen, method of section we have seen, and one concept we have seen yesterday. Only I have told. What was that? Zero force member. To whom we should call zero force member? To whom we should call zero force member? कोणाला म्हणायचं झिरो फोर्स मेंबर? नेम इट सेल्फ इट इज गिविंग झिरो फोर्स मेंबर. द मेंबर इन विच फोर्स इज झिरो इट इज कॉल्ड अ झिरो फोर्स मेंबर. ट्रस मधला असा कुठलाही एखादा मेंबर असेल की ज्यामधला फोर्स काय आहे झिरो आहे तर त्याला आपण काय म्हणणार? विच टाइप ऑफ मेंबर इट इज?
Zero force member.
Zero force member.
then we are going to call it as a zero force member. Then we are going to call it as a zero force member. We are going to call it as a zero force member. Okay. Concept we have seen. What was that? Anybody is remembering yesterday? It was not hard and fast rule, but we can find in that way as well. What was that? Can someone tell? मी काल असं एक डायग्राम काढली होती बघा, आठवतंय का? Yesterday I have drawn one diagram in which there were two members which are collinear. आठवतंय का बघा? हे विचारलं जाऊ शकतं. Maybe in case of multiple choice, something like this. It is not hard and fast. हा rule असाच applicable आहे असं नाही, but sometimes it is applicable. Maybe suppose one something like this, perpendicular. Here it is a perpendicular, maybe something like this. Here it is and here. So if two members are collinear, these two members are collinear, and third one is perpendicular, and there is no load at the end. The load nahi त्याला. That's why we can say it is a zero force member. This one is zero force member. We can call zero force, or it may be inclined, provided that there should not be load at the end. Then we can call it as a zero force member. So on chapter number 3 as well, I will give assignment today. On chapter number 3, only two problems I will give. Only you solve that two problems by two methods. Two problems by two methods. Means how many problems you are going to solve? 4 total. That we will see. You can cross check yourself. I should not tell something. There should be creativity in your. If you want to learn something, you are going to learn many more softwares in your higher classes. In that way also, you should try to apply your we can say mind, your logic. Even in next semester, you are having one of the language called as PPS. One subject is there in your second semester, programming for problem solving. So you are going to write program to problem solving. So you should apply your mind. Only you should not refer to a book. You can apply your own mind and you can solve, you can cross check. Some of the students are doing it's well thing, some of the students are not doing. It is also well thing from their point of, we can say, perspective, not from my point of perspective. Okay. So till now we have seen we are at the, we can say, more than 50%. We are in second half now. आपण आता second half मध्ये चाललेलो आहोत. So chapter number 4 today. Just we will start the things which you know. You can tell to me the things which are related to syllabus. We will discuss. So without taking more time, I will give opportunity to read the syllabus. Maybe the student who don't got opportunity, for them I will give opportunity. Shweta, roll number 3 something. Shweta Dalvi. Shweta Dalvi. Am I audible?
Yes, sir.
Shweta Dalvi, your roll number you are not written. Please unmute yourself. Shweta, you are talking but you are not audible. I think you are in poor network. Then Deeparaj Patil, 55.
Yes, sir.
Deeparaj.
Yes, sir.
Okay. Will you read the syllabus for chapter number?
Yes, sir. Center of gravity, centroid of a composite area, centroid of simple figures from first principle,
Hmm.
centroid of composite sections, center of gravity and its implication, moment of inertia, definition, moment of inertia of plane, sections from first principles, theorems of moment of inertia, perpendicular axis theorem, parallel axis theorem, moment of inertia of symmetrical and unsymmetrical sections, radius of gyration, polar moment of inertia.
Very good. Thank you. Thank you for reading. Things are known to you, I hope. As you have studied a physics subject, these things might be known to you. Maybe, for example, we can say CG and MI. Famously, this chapter is known as CG and MI. Okay, very simple, very interesting. CG and MI. So, have you heard these two terms? CG
Yes,
and
sir.
MI? Very good.
Yes.
So, syllabus is what? Center of gravity, centroid of composite area, centroid of simple figures from first principle, centroid of composite sections. Okay. Center of gravity and its implication, moment of inertia, definition related to moment of inertia of plane, sections from first principles, theorems of moment of inertia. There are two theorems, which is perpendicular axis theorem and parallel axis theorem, and another one is moment of inertia of symmetrical and unsymmetrical sections. Moment of inertia of symmetrical and unsymmetrical sections, radius of gyration, polar moment of inertia. This is the syllabus. So, can someone tell me what is CG and EMI in your own words? We are going to study. Let me know what do you know first. I will not take anybody's name. You can grab this opportunity. The forum is open to you. You are free to put your opinion, irrespective of whether it is correct or wrong. Just I want to be come forward and tell me what do you understand by CG and EMI.
EMI means
Can you-
quantity measure of inertia of body.
Okay, EMI means what? Quantity
Measure of inertia of body.
quantity measure of inertia of body. If you want to say total inertia of body,
Yes, sir.
other, can someone tell? Rutuja has given one opinion, her opinion. Everybody is free to give your opinion. I also check. I also heard first time total inertia. Is it case? Is it the case like this only? Others, please give your opinion. Others,
Mass of body into perpendicular distance between the point and the axis, the square of perpendicular distance between point and axis. असं होतं आम्हाला 12वीला.
ओके, मीन्स यू आर टेलिंग फॉर्म्युला. तुम्ही फॉर्म्युला सांगितला साक्षी, आणि ऋतुजांनी काय केलं की त्यांना त्यांना जे वाटलं ते सांगितलं. की त्यांचं म्हणणं आहे की टोटल इनर्शिया ऑफ अ बॉडी इज मोमेंट ऑफ इनर्शिया, असं त्यांचं म्हणणं आहे. तुम्ही काय सांगितलं? फॉर्म्युला सांगितलं. ओके, विल स्टडी, डोंट वरी. यू आर फ्री टू गिव्ह युअर ओपिनियन. एनीवन अदर?
CG चं फक्त सेंटर ऑफ ग्रॅव्हिटी एवढंच माहिती.
फक्त लॉंग फॉर्मच माहिती आहे तुम्हाला, बाकीच काय माहित नाही? ओनली लॉंग फॉर्म? CG चा लॉंग फॉर्म सेंटर ऑफ ग्रॅव्हिटी. ओनली दॅट मच यू आर नोइंग, or you are forgotten? There may be case that you have studied but you have forgotten. Is it the case?
Forgotten, sir. Forgot.
Okay, no issue.
Yes,
No
sir.
issue. We will study, don't worry, if you have forgotten. So at least you are knowing the long form of CG and MI, moment of inertia. I will check. I got one new
No,
opinion
sir.
here.
Center of gravity means the point at which whole mass of the body is concentrated.
It is a point where whole mass, is it practically possible आहे का हो? असं एखादा पॉइंट असतो का ऑब्जेक्ट मध्ये की त्याचं सगळं मास त्या ठिकाणी असतं? इज इट द केस और इट इज इमेजिनरी पॉइंट?
Yes, sir.
और इज इट कसा? रोहिणी, कसं प्रॅक्टिकली पॉसिबल आहे और वी आर
Yes,
अज्युमिंग
आपण
समथिंग?
सपोज करत असतो, म्हणजे फक्त सपोज करत असतो.
म्हणजे अज्युम करत असतो असं म्हणायचं. Is it the case?
Yes, sir.
We are assuming total mass of the body is concentrated at one point. That point is known as Pg. We are assuming it may be the case. If we'll think more, we will be remain in thinking only. Okay, so it's good thing those who are giving your opinion, we should give your opinion. Huh? So our opinion, and it should be again. There are many more things. So if you'll say, shall I tell one out of syllabus thing which will be important? Suppose placements. Quickly, I will tell. I will not take more time. Placements. Have you heard this term? You are just now in first year. Placements means getting job. Being a graduate, once you are going to be in final year, you are going to appear for placements means to get a job. In that first step, quickly I will tell. First step is to fulfill correct criteria. If there is certain company, then you have to fulfill the criteria. For example, your marks should be more than, we can say 60%, more than 60%, whatever. We can say something like whatever. Marks 60% first criteria. It may be different. I'm telling general. Then second, then you have to go for aptitude test. Aptitude you might be knowing now. In Marathi Buddhimata Chachani. Aptitude test. You might be knowing this you have to go for. After that, third step, once you are going to fulfill this criteria, you have to go for group discussion, oblique debate. So I want to tell this debate. Debate means actually between two opposite opinions groups are discussing. But GD means group discussion. Long form of GD is group discussion, where you are supposed to give your opinion. Point la. Once I am asking opinion, it should not happen that only few students are giving your opinion. Whole class here almost 60. Today almost 57 students are there in the class. So why others are not giving opinion? That also should contribute. जर तुम्ही ग्रुप डिस्कशन मध्ये पार्टिसिपेट झालेला आहात प्लेसमेंट मध्ये आणि तुमचं ओपिनियनच काय सांगत नाही तुम्ही, हाऊ दॅट इंटरव्ह्यूअर इज गोइंग टू कम टू नो दॅट आर यू नोईंग समथिंग, do you want to participate, etc. Further things are also there. Then TI, technical interview, then PI, personal interview, etc. So these many steps are there. Out of that, one is this. Just I have told here, that is GD. So once I'm asking your opinion, you should give opinion. If someone जगात मिळणारी फुकटची गोष्ट म्हणजे आपल्याला सल्ले मिळतात बघा, ऍडवाइस फुकट सांगतात लोक आपल्याला, असं करायला पाहिजे, असं नको, हे फ्री ऑफ कॉस्ट. इट इज जस्ट अ फ्री ऑफ कॉस्ट. दॅट इज अवर ओपिनियन वेदर वी हॅव टू टेक इन टू कन्सिडरेशन ऑर नॉट. फुकटचा मिळणारी एकमेव जगातली गोष्ट म्हणजे सल्ले मिळतात आपल्याला, ऍडवाइस म्हणून. सो यू शुड कम फॉरवर्ड. That I don't know whether you are having communication skill subject in this semester.
Yes, sir.
Yes, sir.
Yes, sir.
Then what you are learning, so you should you take help of such subject to improve your communication. You should come forward. Okay, a technical subject, okay, we can understand, but subject like that, maybe UHV, universal, what is that, human values.
Yes, sir. Universal human value.
In that subject also, once someone is asking something, means we should be able to give position. Okay, coming back to syllabus, this one is the syllabus for our chapter number 2. Okay, there are two things, centroid and center of gravity. So shall I ask what is the difference between center and center of gravity, or centroid? I will say centroid and center of gravity मध्ये काय फरक आहे. First point we will see what is that, whether these two terms are similar or there is something different. What we can say, center of gravity and centroid. If not, we will see. If not, we will see. What is that? Centroid and center of gravity. Most important. First point from the syllabus. What is centroid and what is center of gravity? Actually, these two terms are a little different. It is a point at which whole area of the body is supposed to be concentrated, that we are going to call it as a centroid. Area, it is related to area. What is a center of gravity? It is point at which whole mass of the body is supposed to be concentrated. So somebody just now told the definition of center of gravity. What was that? It is the point at which whole mass of the body is supposed to be concentrated. Okay. On the other hand, it is related with two-dimensional objects. Centroid is related to two-dimensional objects, triangles, any plane. Two-dimensional object, what we are calling? I have told in one of the lectures, maybe zero-dimensional entity, one-dimensional entity, two-dimensional entity, three-dimensional entity. What is the name of two-dimensional entity? आपण काय म्हणतो त्याला फेमसली? एक्झाम्पल दिलं होतं बघा, पेज. व्हॉट इज पेज? पेजला आपण काय म्हणू शकतो? पेज. If there is a page, can we say it is a rectangular plane?
No.
म्हणूया का आपण याला? What is plane? It is a two-dimensional entity having third negligible dimension. If you take example of page, it has two considerable dimensions with negligible third dimension, that is thickness. जर तुम्ही पेजची थिकनेस बघितली तर त्याच्या दोन डायमेन्शन त्या कम्पेअर मध्ये एकदम निग्लिजिबल असते. दॅट इज वी आर गोइंग टू कॉल इट ॲज अ प्लेन. सो व्हॉट इज सेंट्रॉइड? इट इज रिलेटेड विथ द टू डायमेन्शनल ऑब्जेक्ट. दोन डायमेन्शनलच्या ऑब्जेक्ट रिलेटेड असतो तो त्याला सेंट्रॉइड म्हणायचं. मीन्स एरिया. एरिया मीन्स टू डायमेन्शनल एंटिटी. And it is related to three-dimensional entities: cone, cylinder, sphere. Actually, these are also things we are going to learn in the subject called as engineering graphics. Maybe in next semester we are going to learn that subject. Okay, in that subject we are going to learn that three-dimensional entities which are called as objects. Okay, the simple difference: it requires only two reference axes. Okay, centroid requires only two different axes, and it requires three different axes. It is related to volume, something like that we can say. Center of gravity, we are going to call it as a volumetric. It is related to volume. It is related to something like area, we can say. Okay, and their formulas are there. So are you observing? What is x bar and y bar? Suppose there is one point, maybe in here. X bar, y bar. Why? What we are going to call it as? आपण काय म्हणतो? X bar ला काय म्हणतो? X coordinate. Something names are there. Ordinate and axis or something. Are you aware about this?
Coordinate.
Axis or something.
Yes.
Yes, sir.
What is that? Two names are there. Ordinate.
Coordinate.
Coordinate.
Okay, I think coordinate or ordinate. Just check.
Coordinate.
Coordinates.
One is axis. One name is there. To whom it is calling? Just check once again. Whether it is to x or y axis component or coordinate, or simple language we can say x coordinate and y coordinate. Simple language. Actually, it has some other names as well, but we can say something like this: x coordinate and y coordinate. So, what we can learn from this slide? What you can learn from this slide? Centroid and center of gravity. Centroid is related to area. It is related to mass, center of gravity. It is related to two-dimensional object. It is related to three-dimensional object. Okay, then it requires only two reference axes, centroid, and this other is required three reference axes, x, y, z. Okay, in that way. Further, what is x bar, y bar? The formulas are given here. So what are the different formulas? How they are? It is given at the end: x bar, y bar, x bar, y bar. So though we have seen here the different meaning, have you noted down this? Have you noted down this?
Yes, sir.
Are you with me? So though there is a difference, but in our subject, though these two terms are different practically, we are going to take while solving the problem, we are going to take it as one and the same. काय करणार? दोन्हीचे मिनिंग एकच घेणार आहे. And we are related to not we are going to calculate for mass. Means आपण थ्री डायमेन्शनल ला जाणारच नाही. We are going to consider only centroid. For that also sometimes it is called as center of gravity. This I have told. Practically the meaning is different, but once we are going to solve the problem, we are going to consider 2D plane. आपण जे काय कॅल्क्युलेशन करणार आहोत ते 2D प्लेन साठीच करणार आहोत. Okay, so centroid and center of gravity will be, we are going to call it as one. आपण इथून पुढे जे प्रॉब्लेम सोडवणार आहोत त्याच्यामध्ये प्राजक्ता प्राजक्ता रोल नंबर 4. Both terms we are going to take one and the same. Okay, any problem related to this centroid and center of gravity? You can take screenshot or you can write. Shall we go next?
Yes, sir.
Yes, sir.
Yes, sir.
Next, centroidal axis and reference axis. Centroidal axis. Now hereafter, though we have seen here centroid and center of gravity, जरी आपण इथं सेंट्रॉइड आणि सेंटर ऑफ ग्रॅव्हिटी असं म्हटलं असलं तरी, असं आपण इथं म्हटलं असलं तरी आपण काय करणार आहोत, आता दोन्ही टर्म एकच कन्सिडर करणार आहोत. अँड वी आर गोइंग टू स्टडी इन दिस सब्जेक्ट ओनली 2 डायमेन्शनल एंटिटी. वी आर नॉट गोइंग टू कन्सिडर एनी 3 डायमेन्शनल एंटिटी. ओके, वी आर लिमिटेड. आपला सिलेबस हा लिमिटेड आहे कोणासाठी? 2 डायमेन्शनल एंटिटीसाठी. सो बोथ द टर्म्स वी आर गोइंग टू कन्सिडर एज वन. समटाइम्स it may be asked, for a given 2-dimensional figure calculate the center of gravity. असे विचारलं जाऊ शकतं प्रॉब्लेम स्टेटमेंट मध्ये. तिथं म्हणायचं नाही की सेंटर ऑफ ग्रॅव्हिटी हा actually it is applicable to 3-dimensional, but in our this particular chapter both the terms will be taken as one and the same. घेतलेलं आहे. It doesn't mean that we are going to consider 3-dimensional entity. That I want to tell here. Next one is centroidal axis and reference axis. What is centroidal axis and reference axis? Very simple. The axis, first one is centroidal axis. The axis passing through the center of gravity of the body is known as centroidal axis. असा axis की जो center of gravity मधून pass होतो, that is called as centroidal axis. It is as simple as this. On the other hand, the axis which are parallel to the centroidal axis is called as reference axis. Are you able to read on the slide what it is there?
Yes, sir.
Yes, sir.
So centroidal axis means what? The axis passing through the center of gravity of the body is known as centroidal axis. On the other hand, what is reference axis? The axis which are parallel to the centroidal axis is called as reference axis. It is called as a reference axis. Okay. Then once we are going to find center of gravity or centroid of any object, here one thing I want to highlight here particularly. So once we are going to highlight or once we are going to calculate either CG of the objects, we are going to consider our we can say object which is lies in, our object is going to lies in only, our object is going to lies in only, we can say first quadrant. We can imagine that our object is going to be lies here, means once a particular object will be there, in front of us, we are going to get 2 reference axes. एखादा ऑब्जेक्ट दिले समजायचं, समथिंग लाईक सपोज ट्रायंगल इज गिवन, तर तुम्हाला असे रेफरन्स ऍक्सिस इथं लोकेट करायचे आहेत. यू वॉन्ट टू लोकेट सच रेफरन्स ऍक्सिस सच that object will, suppose I will give name to this object something, that object will come in first quadrant. Then how you are going to locate the reference axis? मग कसे करावं लागेल? रेफरन्स ऍक्सिस कुठं करावं लागतील म्हणजे हा ऑब्जेक्ट फर्स्ट क्वाड्रंट मध्ये, maybe there is a center and something like this, we can say it is a central or centroidal axis. मला काय करायचं, जेवढे रेफरन्स ऍक्सिस लोकेट करायचे आहेत, मला असे लोकेट करायचे की हा ऑब्जेक्ट फर्स्ट क्वाड्रंट मध्ये राहिला पाहिजे. काय करावं लागेल?
बेसच्या
bottom.
अँड हाईटच्या अलॉंग.
मी काय करणार, एक रेफरन्स ऍक्सिस बेस मधून पास करणार आणि दुसरा एक्स्ट्रीम लेफ्ट मधून एक करणार. म्हणजे हा ऑब्जेक्ट कुठं राहिला माझा, ऍक्च्युअली मी तर एक्झॅक्ट काढला नाही मेजरने, पण here I will write, then here I will write one axis I have to take at the bottom, so leftmost leftmost and bottommost point of the object. Bottom one will be from leftmost and another will be from bottommost. Another will be from bottommost. Okay, from the object, so that our object will remain in first quadrant. Are you with me? म्हणजे ज्यावेळी एखाद्या ऑब्जेक्टचा आपल्याला रेफरन्स ऍक्सिस काढायचे असते, और वी वॉन्ट टू गिव्ह सेंट्रॉइड, आपल्याला त्याला कुठून तरी द्यायला पाहिजे ना. देर शुड बी सम रेफरन्स ऍक्सिस का वापरले जातात टू गिव्ह रेफरन्स टू द सेंट्रॉइड. त्याचा उपयोग काय आहे? रेफरन्स ऍक्सिस का द्यायचे ऑब्जेक्टला? जो काय त्याचा सेंट्रॉइड आहे, वॉट एव्हर द सेंट्रॉइड ऑफ ऑब्जेक्ट इज देअर, वी शुड गिव्ह सर्टन डिस्टन्स और सर्टन रेफरन्स. Okay, for that purpose it is necessary to have its reference axis. If I will say something like that, suppose Solapur is 75 kilometer away. Suppose I will say something like this, a statement, maybe 75 kilometer away. What is that? Solapur. Yeah, some statement I want. Solapur is 75 kilometer away. Whether it is meaningful statement?
No.
No.
आहे काही मिनिंगफुल? का नाही मिनिंगफुल आहे? मी जनरलीच म्हणतोय सोलापूर हे 75 किलोमीटर अवे आहे, पण कुठून आहे? फ्रॉम वेअर इट इज? देन आय हॅव टू से फ्रॉम पंढरपूर, समथिंग लाईक दॅट. एक्झाम्पल जस्ट फ्रॉम पंढरपूर. फॉर दॅट पर्पज रेफरन्स हिअर दिस पंढरपूर विल ऍक्ट ऍज अ रेफरन्स अँड दिस अवर सोलापूर विल ऍक्ट ऍज अ ऑब्जेक्ट. देर मे बी सेंटर, म्हणजे एखाद्या ऑब्जेक्टचा जर सेंटर आपल्याला लोकेट करायचं असेल, वी शुड हॅव, आपल्याकडे काय पाहिजे? रेफरन्स फ्रॉम वेअर यू आर टेकिंग दॅट. एखादा ऑब्जेक्ट आहे त्याचा तुम्हाला असा सेंट्रॉइडचा आन्सर असेल तुमचं CG इज इक्वल टू सपोज 30 45 असे आन्सर येणार आहेत. आपण CG सांगणार आहे, या ऑब्जेक्टचा CG 30, 45 और कोऑर्डिनेट ऑफ द सेंटर ऑफ ग्रॅव्हिटी आर 30 45. Once you are going to read this statement, immediately you should come to know that हे कुठून आहे, ते 30 आहे, हे कुठून आहे आणि 40 कुठून आहे. So this 30 will be x bar and this will be y bar. And then from where that distance will be x bar? X bar कुठून असेल हो? बघू तुम्हाला इमॅजिन होतंय का? हा, कुठून असेल एक्स बार? 30 हे कुठून असेल आणि 45 हे फ्रॉम वेअर इट विल बी?
X axis and Y axis.
30 हे कुठून असेल? फ्रॉम विच ऍक्सिस इट विल बी?
Positive x-axis.
पॉझिटिव्ह एक्स ऍक्सिस. एक्स बारचं डिस्टन्स हे कुठल्या ऍक्सिस पासून घेतो आपण? वाय ऍक्सिस पासून घेतो का एक्स ऍक्सिस पासून घेतो? फॉरगेट अबाउट पॉझिटिव्ह निगेटिव्ह, आपण फर्स्ट क्वाड्रंट मध्ये असतो. इथे एक ऑब्जेक्ट आहे, मी इथं म्हणतो CG आणि इथं म्हणतो एक्स बार आणि वाय बार. एक्स बार हे डिस्टन्स कुठल्या ऍक्सिस पासून आहे? एक्स ऍक्सिस पासून असतंय का वाय ऍक्सिस पासून असतं?
Y axis.
Y-axis.
Y axis. It is a distance taken on x axis. X axis वर taken, it is taken on x axis, but it is from y axis. आता हे फार बेसिक झालं. We can say it is in 10th or 8th or I don't know in which class you have studied. X bar or x coordinate is the distance from y axis and the y coordinate is the distance from x axis taken on that respective axis. थोडस फार बेसिक ला जातोय, but it is required. For example, if you see here, for example, if you see here CG, for this particular object CG is given and I will write here x bar and y bar. दिसतंय का बघा, मी ऑब्जेक्ट मध्ये लिहिलेलं आहे x bar y bar. ओके, which will be this distance then? मग हे डिस्टन्स किती असेल हो? एवढं डिस्टन्स किती असेल? मे बी दिस मच. याला आपण एक्स बार आणि वाय बार म्हटलं इथे, ठीक आहे. What will be this distance? Either it is x bar or y bar. This horizontal
bar.
distance.
X bar.
X bar.
It will be x bar. From where we have measured this x bar?
From y-axis.
Axis. From y axis. That only I want to tell. Similarly, what will be this distance?
Y bar.
it will be y bar. And from where we have measured it?
X-axis.
X-axis. So here two things you should clear here. Number one, while selecting the reference axis is nothing but the axis which is parallel to the centroidal axis. That axis is known as reference axis. While selecting the reference axis, what care you have to take? सांगितलं होतं बघा few minutes ago. You have to select reference axis such a way that your object will remain in which quadrant?
First quadrant.
First quadrant.
It should remain in first quadrant. So how you are going to select your reference axis? कसं select करणार?
Leftmost and bottom.
Leftmost and bottommost.
Here I have written. You are going to select reference axis in what fashion? One is leftmost, left side of the object, extreme left we can say. Leftmost means extreme left and extreme bottom, so that your objective is going to remain in first quadrant. And accordingly you are going to give coordinates of that center of gravity, x bar and y bar. Okay, x bar and y bar. Are you with me?
Yes, sir.
Yes, sir.
Okay, then most important, there is no, we can say, lot of theories there in this. It will see how it can be calculated. That we have to see now. Centroid of standard geometry. This is most important slide from this chapter. This one is most important slide from this chapter, because whatever standard geometries are there, for that formulas are simple. Suppose there is a rectangle. Okay, rectangle. Then where will be its centroid or center of gravity? Now hereafter I may use the word centroid or center of gravity, so that you can remember here. So centroid or center of gravity of rectangle will be half of the length and half of the width. Simple. Here it is given. So are you observing here y-axis and x-axis here? Here it is x-axis. Okay, this distance, are you observing x-axis, and here it is y-axis. Instead of b and x, it is given. Okay, half of the width and half of the height and area. Okay, that is well known to you in this way. So if it is a rectangle, and once you are going to select extreme left hand side one axis and extreme bottom, so its centroid will come. So what will be its centroid? Shall I write here? Where will be the centroid? Suppose I will give name as a CG. कुठे गेलो? X coordinate किती आलाय आपला? b by 2 and y coordinate किती आलाय? h by 2. In this way, it will come in this way. On the other hand, triangle, which is right angle triangle, or other triangle formula is different. But for this right angle triangle, again we will select reference axis such a way that one is that object will remain in first quadrant. So in that case, its CG will be b by 3, h by 3. So just you can remember, you can write this. Tomorrow I am going to ask cross question on this. These are the standard geometry, but tomorrow I am going to ask different questions. You should remember that. Are you with me?
Yes, sir.
Centroid
Yes,
of
sir.
rectangle. Centroid of rectangle. Then semicircle. So here there is a little change. Y coordinate is taken through the center. Okay, so as per our method, we are going to take this coordinate in this way. आपल्या मेथड नुसार आपण काय करणार आहोत? In this way we are going to take, this one is x and this one is y. Okay, so here x coordinate, what will be x coordinate? X coordinate किती असेल हो? इथं त्याचा सेंटर आहे बघा, CG, or I will write G. What will be the distance this x bar equal to काय असेल हो?
Radius.
Yes, very good. It is radius. And what will be y bar? It is standard 4r divided by 3 pi. So here CG will become, center of gravity will become r, and 4r divided by 3 pi. Are you with me for the semicircle? Are you with me?
Yes,
Yes,
sir.
sir.
Yes, sir.
So CG will be R, 4R divided by 3 pi. Next, quarter circle. Next will be quarter circle. So here already it is taken Y, and here it is X. Y and X. Okay, so here it is a CG, or I will write G. So its CG will be, its CG will be 4R divided by 3 pi. Okay, and here same 4R divided by 3 pi. Symmetrical. 4R divided by 3 pi, 4R divided by 3 pi. Okay, CG. And parabolic segment, rarely it is used, rarely. But you can remember this as well. Parabolic segment. Okay, so CG is here, X distance and Y distance. Very rarely it is used. So for your information, not required, but you can write. IUB, parabola, have you came across this? Parabola, hyperbola, again one more is there. What is that?
Ellipse.
Ellipse?
Yes, sir.
Okay. So this is rarely used, don't worry. But we should remember this parabolic. Okay, in this way. What is that? We can say that half of the distance is B, height is H. Then the centroid is given. Okay, in this way. 5B by 88, 2H by 3. Okay. Have you noted down this? Whose next lecture is?
Basic civil.
Basic mechanics, basic civil engineering.
This is mechanical or civil. Okay, whatever it may be. Suppose one standard geometry we missed. If I will take suppose, if it is not possible, just I will ask. Suppose what will be the centroid of circle? Maybe something like that. I will draw something like that. There is a circle of radius r. याचा centroid किती असेल हो? एक सर्कल आहे की ज्याची रेडियस r आहे.
R.
Apply the mind and tell me. Just I'm asking. What will be that?
RR, sir.
R. Very good. Such kind of logic is required immediately. So it will be R. How? Once you are going to take in this way, axis, maybe something like this. Okay. So this distance will be R, and this distance will be R in this way. Okay. So this center of gravity will become, or center of radius will become R. On the other hand, suppose there may be quarter circle, maybe something like this. Here, maybe something like this, and here there is a CG. Okay. For this now tell me where it will be CG. CG कुठं असेल याचं काढू शकताय तुम्ही? ज्याची रेडियस R आहे. 1/4 circle whose radius is, we can say, R. काढू शकता ना? Is it possible for you to calculate this? नाही सांगता येणार किती असेल? काय करावं लागेल? आपलं मेथड काय सांगते? We have to select reference axis. In what way? That object should remain in
First quadrant.
first quadrant. So let us apply that procedure. So I will draw axis from here. So it will be x-axis. I will draw axis from here. Maybe something I am drawing blindly. So y. Maybe something like this. And here it will be this. So we know this distance. हे distance आपल्याला माहिती आहे. हे पण distance माहित आहे. कारण आपला standard formula पण बघितलेला आहे. What was that? Second last formula. 4r divided by 3 pi. 4r divided by 3 pi. Okay, what the way we have seen that geometry. That's why I have told. Remember that geometry. So 4r divided by 3 pi. Where it is? Means this distance we know. How much it is? How much it is? 4r divided by 3 pi. And how much it is? 4r divided by 3 pi. Then if you will go for हे डिस्टन्स पाहिजे आपल्याला. एक्स बार हे जे डिस्टन्स आहे कसं काढावं लागेल एक्स बार वाय बार
R minus
R
four
minus
4R
4R
by
by 3 pi.
4r divided by 3 pi r minus 4r divided by 3 pi. So what it will become? Just check. काय येईल मग? मी इकडे सिम्प्लिफाय करू का? r minus 4r divided by 3 pi. If I will take r common, what it will become in bracket? 3 pi minus 4 divided by 3 pi.
3 pi.
Similarly here also same thing. So total will remain outside, or we can see in this way, or it is something like this. Formula we are not necessary to calculate, but in this way we can calculate, or simply here also we can say it is also sufficient, not necessary to go for further calculation. R minus 4r divided by 3 pi, that is also sufficient. Suppose next, if I will do maybe something like this. Oh, sorry. Maybe something like this. Right angle, the triangle. Okay. And here, what is it? CG. Who will tell? CG किती असेल? We know while selecting the reference axis how we should select. सांगता येईल, कॅल्क्युलेट करता येईल. आता इथं कुठंतरी CG असतो याचा G. त्याचं डिस्टन्स किती असतं असं पाहिलं आपण. हे डिस्टन्स किती असतंय आणि हे डिस्टन्स किती असतंय. Suppose we will take this total is, suppose I will tell length and this is height. मग आपली रेग्युलर मेथड काय सांगते? L by 3
H by 3 and L by 3.
H by 3. But total is L. आपल्याला हे डिस्टन्स पाहिजे ना. आता काय करावं लागेल?
2L by 3 2H by
minus
3.
L minus 2H by 3. Okay, you are simplifying. And another one is H minus H by 3.
By 3.
So what it will become? 3L minus 2, 2L by 3, 2H by 3. See. So tomorrow we will discuss this, all the things. Meanwhile, okay. So likewise, I will ask you a question tomorrow as well. So meanwhile, are you with me? Though the geometry is rotated through certain angle, etc., you should be able to find its center of gravity. That was I want to tell. Are you with me?
Yes, sir.
Yes, sir.
So, though here there is standard geometry, so for that purpose, the standard geometry is most important. These formulas are most important. If you know this better, if at all the geometry is rotated through certain angle, you will be able to find that as well. Okay. With this, we will stop for today. Tomorrow we will solve problem. Please prepare this slide very well, because on this slide only all the problems will be there. Okay. Any problem? Roll number 12 absent. Twelve 27. $45 is there. Okay. 46, 47, 51, 53, 56, 57. Is there any problem? If not, we will stop further. What is your roll number, Shweta? I think 3 or 1. 5.
Yes,
Okay.
sir. 5.
Okay. We will stop for today.